Alright guys, we're going to do vodcast 5.5. This is going to be part 2 of electron configurations. This one's going to be a little bit shorter because we've already done the basic what are electron configurations and how do we find sort of the hardest model. But as you guys probably noticed, that doing electron configurations the way we were doing them in the longhand model is long. I mean, it's tedious and it takes a little while. So we're going to talk about how to shorten this up. And the first way that we'll do that is with something called shorthand electron configuration. Okay, so real quickly, whoops, hold on, I lost my pen tool. So real quickly, we're going to go back and talk about the first one that we did yesterday, or the second one that we did the other day, was we did electron configuration for iron. Okay, so we had 26 electrons in iron, and so we're going to draw all those in. Okay. Sorry for the slight sloppiness. I've got a small slide here, but I'm just getting to the shorthand part. If you look back in your notes, you should have this orbital notation, wow, that's really bad, written down for iron. So we had 26 electrons, which meant that we got up here to 3D, and in 3D, we had 26 electrons. We had 6 electrons left in 3D. Okay? Now, again, first off, you have to figure out where you need the boxes, draw the arrows, all that stuff. And so what you probably start thinking to yourself is there has to be some slightly easier way to do that. Okay, and the good news is there is an easier way to do that. Okay, so we're going to take that 26 electrons and we're going to put this into what we call shorthand. So here's the way shorthand works. To do shorthand, you name the orbital, okay, and then you write how many electrons are in it as an exponent. Okay, so 1s, 2. Okay, so real quick, this part is the orbital, okay, or sublevel. Okay, and this part is the number of electrons in that orbital. Okay, so I'm going to finish this one up. So 1s2, I've got 2 electrons there. 2s2, okay, that's this one. Next is 2p6, okay, 6 electrons. 3s2, okay, 2 electrons. 3p6, 1, 2, 3, 4, 5, 6. 4s2, okay, and then 3d6. Now, the way this should work, a couple of important things to note is that everything but the very last one, or maybe the last 2, should have their maximum number of electrons. So S's all have 2s, P's all have 6, D would have 10, except that this is the final orbital, and so therefore it doesn't have a full 10. We end here, and that 6 sort of lets you know that's where that ends. Your check, just like we did before, okay, is to run through and make sure that you have 26 electrons, because that's what iron should have. If we look up iron on the periodic table, it's got 26. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, 18, 20, 26. Okay, so we're golden. We've got the right number of electrons, and that's shorthand. So I'm going to walk you through a couple more, and you'll see that this can be pretty easy. And in fact, it's real easy if you have it drawn out, but if you have this drawn out, shorthand isn't short, because if you have to do longhand first, then it takes a while. So of course the easiest way to do that is to use the periodic table. Okay, so here's going to be our trial run right here. We're going to do manganese first off. Okay, so real quick, just to make sure that you can see everything, let me blow you up a periodic table here a little bit so you can see it a little bigger so that you know what we're looking at. So manganese, whoops, manganese is right here. Okay, so that is element number 25, which means that we have 25 electrons. Okay, so we're going to write that down. I'm going to write that up here in the corner so that we know that and can work from that. So 25 electrons. Okay, and then we're going to real quick here, let me just shrink back our periodic table because we only needed that to find it out. And by the way, you should have a periodic table in front of you while you're working these and getting these notes. If you don't, you're just making life miserable on yourself. Okay, so 25 electrons. And then I'm still going to use my periodic table. I'm going to keep it a little smaller because I don't really need to read the numbers now, but I am going to go along and write the orbitals as I go, because that's what I need to do my shorthand. So we're going to start with 1s, and 1s goes 1, 2, so we filled that up. So 1s2, 2s2, Okay, 2p6, so I'm not there yet. I'm at 10. 3s2, okay, 3p6. Now, where am I at so far? If I just stopped here, I've got 2, 4, 10, 12, 18 electrons, so I've still got a ways to go. So we come down to the next row, 4s2, okay, and I'm getting close here, so remember this is 3D. It's not 4D, it's 3D. D's are always one lower than the S. And then manganese is in that row, and how many over is it? It's 1, 2, 3, 4, 5. So 3D, 5. And then we go back and count. So 2 plus 2 is 4, plus 6 is 10, 12, 18, 20, 25, and so I've got it. Now, as you can see, I whipped that out a whole lot faster than I could have done all the drawing of the boxes. And I could have done that. I mean, we could have started with 1s and 2s and 2p, but I mean, like, that would take a long time. There are occasions where you need the orbital rotation. It helps out a lot, but then there are a lot of cases where all you need is the electron configuration, okay? So that's how we get to that. So let's work another one of those, and then we'll introduce the third method. So let's do platinum. We haven't done much this far that is really far up there. So platinum is right here, and it's element 78, okay? So that means that I've got 78 electrons, all right? And I've got a long way to go through the table, okay? So I'm just going to walk through. So 1s, and in fact, I'm going to go as far as we did before. So 1s, 2s, 2p, okay, 6, 3s2, 3p6, okay, so right now we're right through here, okay, 4s, 2, 3d10. Now, how do I know that I keep going to 10? Well, because 3d10 ends at 30 and I need to go down to 78, so I got a ways to go yet. So 3d10, 4p6, okay, so 4p6, come back to 5s. Oh, what just happened there? Crazy marker. Okay, let's try that again. So 5s, 2, okay, then 4d, remember the d's are always one less than the s they're next to, so 4d10, okay, still not quite in the right row. When I get down to the next d level, I'll be where I need to be. So 4d10, 5p6, okay, again, sorry for that craziness there, okay, down to 6s. Now, remember when we get down here to 6s that the next thing is this little cutout here. The cutout comes down here to F, okay? So we got to put that in. So that's the first F block, and remember the top one is 4F, and it holds 14 electrons, okay? Now that's pretty close to where we want to go, because once I fill that in, I come back up here, and I'm at 5D, and that's where platinum is, and so I need to count over. So 1, 2, 3, 4, 5, 6, 7, 8. So I put an 8 there. And then we're going to go back and total these up. Now, when there's a bunch of them, I kind of like to break them into small pieces. Okay, so that's 10. Okay, that gives me 20 total. Okay, 30, 36, 38, 48. Okay, 54 plus 14. Okay, is, oh, now I feel like I messed something up here. Oh, whoops, I didn't put the 2. See, and this is a good exercise because I put my 6s in there, but I didn't put the 2. My electrons weren't going to add up then. Okay, so 54 plus 2 is 56, plus 14 is 70, and then when I get to the end here, 78. That was a great example. I forgot to write the 2 there, and so my electrons didn't add up. And that will let you know that you missed something and that you should go back and correct that. Okay, so that's shorthand, and we'll definitely get some practice on those. Now, let's make it even shorter. Okay, shorthand was all well and good, but when we wrote that platinum out in the last one, that thing is still pretty darn long. I mean, it's not as long as drawing out all the boxes, but it's still long. So we want a shorter way. So we're going to do a way called noble gas core. If you remember, if you look on your periodic table, row 18 right here, okay, those are called the noble gases. Okay, called noble gases because they don't like to react with stuff. Now, we're going to talk in the next section that we want to get to noble gases a lot. That's what elements want to get to. But what we're going to do here is we're going to use noble gases to make our electron configuration easier. So here's the way it works. We're going to do platinum first. Take the element you're looking for. Okay, so I'm at platinum. I need 78 electrons. And here's what you do. You go all the way over to the end where the noble gases are, and then you jump up one. Okay, so I draw my line. I go all the way over, and then I go up one level, and I end up at xenon. Okay, so whatever you get there, you write that element symbol, and then you put it in brackets. That is what we call the noble gas core. Now, I'm not done, but that's where I start at. Okay, now what this does is this xenon takes up 54 electrons worth of my configuration. So I'm to right there, its atomic number is 54. Okay, so that means that I've got 54 of them here already taken care of. Now, what I do now is I take the next step. I keep going where I would normally go from xenon. So I wrap back around the table, okay, and I'm going to write the rest in a different color so we can tell where we went here. And now I'm at 6s, and so I just continue on doing shorthand the way I normally would. So 6s2, jump down here to 4f14, which should look familiar because we've already done platinum, okay. Whoops. Sorry, stray mark. Let's get rid of that so that doesn't confuse anybody. Okay, so 6s, 4f14, and then we're back up here to 5d. And just like before, we count over 1, 2, 3, 4, 5, 6, 7, 8, 5d, 8. Okay, now again, do a quick check. Okay, make sure that you're right. So I've got 54 plus 2 is 56, plus 14 is 70, plus 8 is 78 electrons, which is exactly where I want it to be. Okay, let's work another one of those real quick, a little simpler one, but just to make sure that we know what we're doing. So we're going to do, in this case, let's do arsenic. Okay, As, okay, it has 33 electrons, and it wouldn't take us that long to write the whole thing out. Let's go ahead and do noble gas core. Okay, so arsenic's right there. Draw my line over the noble gases, and then I go up one. Alright, now since I wrote all over it, it's kind of hard to see what that is, but the up one right there is argon. Okay, so my core then is Ar, put that in brackets, okay, and then I start at the next box. So argon's at 18, jump down here to 19, where is the next one, so that's 4s, okay, come through here, so that's 4s, 3d, I got 10 in the D. And then now, we're starting right here, I'm at 4p. And so it's 1, 2, 3 over. Then we just want to count them up. So argon takes care of 18 of them because its atomic number is 18. So 18 plus 2 is 20, plus 10 is 30, plus 3 is 33 electrons, which is what we had. And so we're golden. Okay, we're going to work through a bunch of each of these in class, guys, so don't panic if you're not getting it now. I'll be there to help you. But you might want to pause the video, go back and watch it again so that you've always got this so you know what's going on. Thanks again, guys.